Okay, so now we're going to talk about the rational zero theorem. And what do we mean by rational zero? We're talking about a zero that's a rational number. So numbers like 2 and -5, those are rational numbers. Or you could have something like -1/3 or 5/6 or something like that. Those are rational numbers. So we're talking about zeros that are rational numbers. We're not talking about zeros that would have I in it, or like the square root of 7. We're not talking about those zeros. Okay, those are possibilities, but this theorem doesn't apply to those. Okay, so let's say we have a function in general form. Okay, something like that. And then we have that leading term at the beginning, and we have a constant at the end. So the rational zero theorem, what you do is you look at the constant at the end, okay? And you want to look for the factors of A naught, okay? So let me explain what a factor is. So let's say A naught is 12. Then when we're talking about the factors, we're talking about all the numbers that will, integers that will go into 12 evenly. So like 1, 2, 3, 4, 6, and 12. All of those would be factors of 12. Now they could be positive or they could be negative, and I'll tell you how we take care of that in a little bit. Okay. So you're going to find the factors of the constant. We call those P. Then you're going to do the factors of the leading coefficient. So the factors of A sub n. We call those Q. Okay? And then the possible rational zeros are any P over any Q, and then you do plus or minus for each of those, okay? So there'll be like, several of them. Sometimes there's only, 2 possibilities, but usually there's more. Okay, so it's probably easier if I show you on an example. Let's see, one more thing I was going to say. These are just telling you possible rational zeros. They're not telling you what the zeros are, okay? I just want to emphasize that. All right, so it says list all the possible rational zeros of, and then it gives us this polynomial. So we're going to look at that 4 at the end. It's a -4, it doesn't matter, because we're going to go back and do all the plus or minus when we get the factors. So I'm just going to consider 4, oops, let me erase that, the factors of 4. So what numbers go into 4? 1 is always going to be a factor. 2, 4, and then I look at the leading term to get the Q's. Okay, so this one gives you the P's, and this one gives you the Q's. Okay, so factors of 2. So the factors of 2 are 1 and 2. All right, now to find P over Q, you're going to take each P over one of the Q's. So it's going to be 1 over 1, 1 over 2, 2 over 1, and 2 over 2, and then 4 over 1, and 4 over 2. Okay, so those are all the factors, each P over each Q. Now I'm going to simplify them. So 1 over 1, that's 1. I get 1/2. I get 2. I get another 1, but I don't need to write it again. I already have 1 as a possibility. And I get 4. That's okay. And then this, see, that's going to equal 1/2, but I already have that. So this one equaled 1. So you don't have to repeat them. All right, and then put in the plus or minus, and then that gives you all the possible rational zeros for that function. There are 8 possibilities, plus or minus 1, plus or minus 1/2, plus or minus 2, and plus or minus 4. So those are the possibilities. Now you might say, well, that's not doing me any good. I want to find the zeros, and how does that help? Well, when they give us a polynomial, and they don't tell us a factor, or they don't give us any more information, we're on our own to find the zeros. And so we don't want to try every number that's out there. That would take forever. This narrows it down to just 8 possibilities. And remember, these are only the rational zeros, okay? But at least it narrows it down for us, and it gives us a place to start. And we're going to see that in some examples as we go on, okay?